Okay? And an equation that looks like horizontal line, is it x equals a number or y equals a number? Y equals some number. It's backwards from what you think it should be. A vertical line has a slope of undefined. And an equation that looks like x equals some number. Okay. A slanted line has a graph of y equals mx plus b, where m equals slope and b equals y-intercept. And when we're graphing a line, we're going to plot the y-intercept. Well, solve the equation for y first, then plot the y-intercept, and then use the slope to find your next point from there. Okay, so last night you were supposed to graph these, and I should have had these filled in. So x equals -5. I'm going to run through these quick, so if you haven't done it at all, you're probably not going to be able to fill it all in. X equals -5 should be a vertical line here. I saw a lot of you with that one wrong. Okay, so on the x-axis, you're going to put dot at -5, and you have to have a line that goes across that.
I got the vertical line, but I accidentally put my dot on the -5. Yeah.
Yes, careful. It is, unless it's x equals 0, y equals 0, it should not be on top of the axis. So if you find yourself like graphing it and it is the x-axis or the y-axis, the only time that's going to happen is at either x equals 0 or y equals 0. So if you've got like x equals 2, you've done something wrong if you're getting it on top of the axis. All right, here you should have a line that looks like this. For number 2, you got y plus 4 equals 8. That's not solved for y. You got to subtract the 4. So y is going to equal 4. All right. This is going to be a horizontal line. So on your y-axis, you're going to go to 4. And then horizontal line, it's going to go across here at 4. And then for 4, you should have a graph that looks like this. Okay, questions? I saw a lot of you missing number 1 and 2 with those vertical and horizontal. It looked like 3 and 4 were better, although I can't count them exactly as I'm just running around to check. So make sure yours looks right. Okay. Now, whenever we get to number 5, this is not solved for y. You got to move the x over, so it's going to be y equals -x plus 5. Which will look like this. Over here at 8, you get this graph. For 6, that has a y-intercept at 0 since it doesn't have a y-intercept listed there. You can put a plus 0. And negative 2 over 5. That's 4. Nine, you've got to solve. Negative 24y equals 48 minus 12x. Divide everything by negative 24. You will get y equals negative 2 plus 1/2 x. So negative 2 up 1 over 2. That for 7, you got 9 minus 4x. That's going to be negative 3 plus 4/3 x. So negative 3 up 4 over 3. And the last one, y equals 3x, so y equals negative 5 plus 3x, so negative 5 up 3 over 1. Alright, so I'm running through those quickly because it's a review. There, is there any part of that I need to go back over? Any questions you guys have on anything? Six. Okay, so what's the problem on number 6? Because it's a little tricky. It's a little different than others. What is confusing about it, Julian? Okay, so that negative 2 over 5, is that your slope or your y-intercept? Slope, because it's beside of the x, right? So that is your slope. So you need a y-intercept to start from, right? If there is nothing there, you can put a plus 0 on the end. So if we put a plus 0 there, we'll put a dot at 0. And then when we have a slope of negative 2 over 5, that negative can go top or bottom, or just know that your line needs to be decreasing since it's negative, right? So instead of going up 2 to the right 5, we need to go right here, down 2, and to the right 1, 2, 3, 4, 5. There. And then you'll keep doing that till you get that line. You're welcome. Other ones that you guys were a little mixed up on. All right, good news is that if you can graph, then this section should be pretty straightforward for you. Because if you can graph, all we're going to have to do is graph 2 lines together now. Okay? So, let's go on to the next section. So, and I'm going to zoom in a little more. I realize my words up here are probably a little too small for you to read, especially those of you that might have eyesight problems. You know, my classes this year have the worst eyesight I've had in a long time. I don't know I don't know if it's just a coincidence or if there's a reason for it. You guys actually are better off than my calculus class. My calculus class is awful. Huh? I think Ethan's got good eyesight. And Thomas McComb and Jackson Mudio tell me that their eyesight is 15, 20. Or 20, which one is it? 15, 20? Better than 20, 20. So they're pulling the average of the class up. But at one point, one kid's glasses broke, and he had to have his cell phone out and would use it like a magnifying glass to see what was on the screen. So, I don't know if it's like pandemic people haven't been able to get to the eye doctor, or if it's just like a coincidence. If y'all sat at home and ate like I don't even know. Maybe you sat at home looking at screens for a year straight and it's damaged your eyesight. What is this possibility?
No, it is.
I feel like it's probably just like an abnormally, like, I feel like it just probably would always go up and down a little bit on good or bad eyesight. But I'm telling you. Oh, it keeps on getting worse pretty much your whole life. Yeah. Now, yeah, I feel like, I know every time I go to the eye doctor, my prescription it needs to be just a little bit stronger every time. But they tell me that's normal, that it's not getting.
Do you wear glasses all the time or just part?
I would wear glasses all the time if I did not have to wear a mask. But when I wear a mask, it fogs up my glasses and I can see good enough without it. I'm not restricted to them to drive, so my eyesight's not terrible, but I would prefer to wear them all the time. But when they fog up, it makes it to where I'm just better off without them. And I tried many different types of masks last year with no success. So yeah. Yeah, when I was still experimenting before I just gave up the glasses altogether, like, there were a few days where I got the mask just right and I could actually see, but overall I never figured out what the secret was there. So, since my eyesight's not terrible, I've just given up the glasses, but if my eyesight was worse, I would have probably had to think harder on that. Some people told me to get the, like, spray for your glasses that, like, makes them not fog up. But I was afraid it would mess up my, like, anti-scratch coatings and stuff like whatever else. Yeah. Yeah, yours don't fog. Your glasses are also, like, a little bit bigger. I wonder if that helps, too. I don't know. Yeah. 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 So, anyway, I just gave it up. But I would prefer to wear glasses all the time, but I don't have to. So, when solving systems of equations, you want to find the solution and I'm going to put in parentheses right here, ordered pair, meaning like x, y coordinates, that makes both equations true. Okay, so I'm going to show you the first method that you could try to use, and that is guess and check. This will be Owen's favorite. He's going to try to guess and check on everything, since he's a mental math master. So, if I look here, I want to think, like, what ordered pair could I plug in? So maybe that bottom one is x plus 6. So let's say I plugged in 0, right? Then what y coordinate would I get if I plugged in 0? 6. So 0, 6 would work for that bottom one, right? But if I plug in 0, 6 up here, 6 equals 3 times 0 minus 4. 6 would equal 0 minus 4, so 6 would equal negative 4. So 0, 6 works when I plug it in here, right? 6 equals 0 plus 6. That is true, but this one's not true. So 0, 6 is not a solution to both of these systems. So 0, 6 is out. I have ruled out one out of infinitely many solutions, right? So I could guess another one. What's another one we could try? So I need like the ordered pair, the x and the y coordinate. 2, 12 won't work for either one of them. All right, so 6, 8 would not work for either one. Let me show you why. Okay, because this is a good review also, because this is like determining solutions, right? So I gave you some of those questions that you saw that said, is 5, 7 a solution for this equation? And it was the one we kind of didn't do very well on. So like 6, 8 is what Peyton said, but you just kind of came up with that, right? So like if I plug 6, 8 into the 6 right here for x and the 8 right here for y, right? So 8 equals 3 times 6 minus 4. So that would be 8 equals 18 minus 4. Is that true? No. All right, well, let's try this for the bottom equation. 6 and 8 here. So 8 equals 6 plus 6. Is that true? No. So 6, 8 wouldn't work for either one of them. All right, so Owen's telling me to try 2, 2. All right, so if I try 2, 2, right, I would plug in 2, oh, that's wrong, 2 over here for y, I'd plug in 2 for my x. So 2 would equal 3 times 2 minus 4. So 2 would equal 6 minus 4. Is that true? It works here. Does it work on the bottom? 2 equals 2 plus 6. So 2 equals 8. That does not work. So 2, 2 worked on one of them. All right. So check them and see if you can figure out which one it is that works. So and you have to wait for at least 45 seconds before you can tell me. He's not a cheater, but he is fast. His mental math skills are impressive. His completion of tests accurately could improve. If he would possibly take 20 minutes instead of 12 minutes to take his test, he might do a little better. Depends on what test it is. Don't graph them yet, but that's what we're eventually going to do.
Do my process. I take forever to still do that.
All right, what do you think, Marley? All right, so Owen's guess, Marley has checked it. She says she thinks it's right. So if we check it, 11 equals 3 times 5 minus 4, which means 11 would equal 15 minus 4. Is that true? Yes. All right, and then over here we'd have 11 equals 5 plus 6. Is that true? Yes. So our solution for this is 5, 11. But our guess and check method could potentially take forever, right? Even for Owen, on some of these, like let's say I made that y equals 2/3 x minus 7. Then it'd take a lot longer than it even took us this time, right? So guess and check is your last resort sort of option that you really would rather not use. So what we can do, and the method we're going to focus on today, is we can graph both equations and find their intersection. Yes. Oh, wait. All right. Okay, so if I graph both of these, I've got the first one, I got a y-intercept at -4, a slope of 3. Please draw your line before you start graphing the next one. Because if you don't, all the dots start to run together and you might do crazy stuff. And then the second one has a y-intercept at 6 and a slope of 1. Now this one does sort of run off of the graph here, but we can tell pretty easily, oops, there went my line. Draw this out a little bit longer. That if we just went one more dot right here, they'd cross right here. And so that point would be 5, 11. So 5, 11 is our solution. Yes? -4, because we're graphing y equals 3x minus 4. Alright, so maybe I should use different colors, but y equals 3x minus 4, that was this line right here. And then I graphed y equals x plus 6, that was this line right here.
Okay.
And you're just seeing where they cross.
I got it.
But how do you determine the y-intercept? Because it touches on 2 times. Because, I mean, it doesn't also touch on like -4 and 5.
No, so your y-intercept in the equation, that's where you graph the line. You don't need a y-intercept in
Yeah.
Your coordinates are included.
Yeah, so like right here, whenever I'm looking at this point right here, I'm just looking right here. I count over 1, 2, 3, 4, 5. That's my x coordinate, right? And then it kind of ran off the graph, but this would be 11 right here. So 5, 11. You're just giving me the coordinates of that point.
If it's y equals like 5, you're gonna go up 5 and then go over like this, right?
Right, it's a horizontal line if it's y equals 5. Alright, so for number 1 here, let's see, Julian, what is my y-intercept for that first line? Y equals 2x plus 5. 5. So I'm going to go up 1, 2, 3, 4, 5. I'm going to put myself a dot. What's my slope, Julian? Alright, so I'm going to go up 2 to the right 1. And I would suggest like drawing your line on out and trying to draw it very carefully. If your lines are crooked here, you'll get the wrong answer. Okay? So you need, see how I did the dots all the way out? I didn't just, a lot of you are bad to like draw your line like this. And you don't draw the whole thing. It might work if it crosses close by, but if it doesn't, then you'll get it wrong. Let me use a different color for the other line. Let's use red here for y equals 9. So y equals 9, what type of line have we got there for y equals 9? Horizontal. So y equals 9 right here. We want to go across here. And we are looking for where these two intersect, so where they cross, right here. What are the coordinates of that point? 2, 9. So 2, 9. And, now I'm not going to make you check on every one, but if we want to check, and sometimes we do, to check. Right? If I plug these numbers into the original here, 9 equals 2 times 2 plus 5, so 9 equals 4 plus 5. That works. Here, I would only have the y to plug in, 9 equals 9. That also works. So it works in both equations. So that guess and check we were using at the beginning, you can use that to check once you have an answer. Might be especially helpful if you're a little unsure of your answer. There. Okay, questions? All right, I'm gonna let you guys do some of these on your own. I'm gonna skip down and do number 3. Because for number 3, we've got 4x minus y equals negative 3. Do we know the y-intercept of that? We do not. Do we know the slope? Not like it is right now. What have we got to do, Wade? Okay. So we'll subtract 4x from both sides. So that gives negative y equals negative 3 minus 4x. And then what would we do, Wade? So we end up with y equals 3 plus 4x. So if you have an equation that's not solved for y, you've got to solve that for y. Let's see, Caroline and Julian, will you shut your computers for me right now? We don't need them right now. A little bit. All right, so Wade, what's my y-intercept to that line? Are you sure? Positive 3. And then what is our slope? Okay, so what should I do? Okay. Right. Okay. Okay. We'll finish this hand. And let's see. I gave. Let me give you one of these. This is what we're doing now. Okay. All right. Yes. Yeah, running out in the cold can be bad on you. All right. So, all right, that's our first one. That was this one right here. Any questions? Got that? All right. Let's do the second one. It's already solved for y for us. Peyton, what should we do? Yep. Correct. And yes, and thankfully you can kind of see right away where they cross right there at negative 1, negative 1. So that will be our answer. And you can always plug those in to check if you're unsure. Feel pretty confident on that one because it graphed pretty easily. Okay, questions? All right, so that is basically, pretty much it. It's just graph them, see where they cross, which I don't think you guys need me to sit here and do all of them for you. So I'm going to give you guys a few minutes to do this on your own. After about 15 minutes or so, I'm going to put some up on the screen here. If you are finished and have your answers, let me know. I will check them and you can start the Delta math. And we will go over these real quick. That you don't get an answer at all. One of them happens on number 6. Okay. So if you move the 2x over here, you got y equals -2 minus 2x. So if we graph that first one, we got +2 and then a slope of -2. And so we get this line right here. And then if we graph that second one, then we're going to have a y-intercept at -2. Actually, let's graph in here. And then we have a slope of -2 over 2. And if we had thought about it before we graphed them, those two lines have the same slope. What do we know about lines that have the same slope? They are parallel. So, do they ever cross? No. So, if you have parallel lines, these never cross, so this is going to be no solution. Okay. You probably did something wrong on number 2 because let's see. Let's do number 2. Let's do 2 together. All right. So for 2, you're gonna have a y-intercept at 3 and a slope of 5 over 3. So we'll have this line right here. And then we've got y-intercept at -3 and a slope of up 1 over 3. And here is your problem for this one. We can see where they cross, but do they cross at a perfect location? They're not crossing like perfectly on the grid lines there, which is one reason that this method is okay, but we're going to need to learn some other methods, right? So, so this sometimes happens. So if this happens, what we have to do if we're using the graphing method is we kind of got to guess what this is and check to see if it works in the equation. So I would probably go with like -4.5 and -4.5. Here. I will, you will only have this one. I think that this happens for because I was mostly just wanting to make a point of it. You'll have 5/3 times -4.5 plus 3, and we want to see if it equals -4.5. And I'm going to let you use the calculator here. Don't run and get one because it's only going to show up on this one. Here, 5/3 times -4.5 plus 3 is going to give you, this ends up being -4.5 when you type it into the calculator. So it works for this one. You also want to check the other one. And if you type in 1/3 times -4.5 minus 3, you also get -4.5. So that one works as well. So this would be your answer. But that's not the best way to solve, right? So I mostly put that one on there, and I should have done a couple more problems before I let you guys go. I usually do all of them, but you guys seemed like you were such good at graphing and working ahead of me already, so so I quit. But I put this problem here to let you know that as easy as graphing is, it's not the best method, right? For some situations that we're going to get, because it's good when they cross on grid lines and when the graphs fit on the graph, but if it doesn't, it's not great. It's also good if they let you use Desmos, because if you could use Desmos, we could graph them and see where they cross really easily, right? But usually you have a calculator inactive section of that Math 1 exam, and usually these are calculator inactive. And if you have to take this exam for this semester, it's going to be calculator inactive, so you wouldn't be able to do it on Desmos. I do not have an example where this happens, but we should add this in maybe down here at the bottom. What happens if you end up graphing and they end up being the same line, if they graph right on top of each other? One word that we did use for that is coincide. So where do they intersect if they're coinciding lines, if they are the same line? Everywhere, right? So you'll say infinitely many solutions. So if they end up being the exact same line, then you would say infinitely many solutions for that, because they're going to touch everywhere. It doesn't happen on these example problems, but it might on your Delta Math. I'm not sure if it does or not. So finish up those others. I'm going to check as you go.
So at some point it meets, but I don't know where.
It looks like one tab.
Okay,
11.
0 or 0, 11.
Do your Delta Math.
0, 11, 8. What? 0, 11.
Actually, it is 12.
12?
Here, yeah. Because it's like it's 3, 1/3. You got to down 1/3. So it is.
Where's the Delta Math?
Not there? Okay. Let me check it real quick. That's good. Let's see that. Try that one again. Okay. Actually, I got a negative. One should be positive, one should be negative. Yeah. So check that one again. All right, Delta Math is not up, so let me change.
This Delta Math right here, that was due November 3rd, was that an assignment?
It's probably just one that I just look at the grade on. Yeah, it was an assignment. But you check. Don't rely on anything in Delta Math, because sometimes like this one's telling you it's late, but it's not really late. I just changed the due date and I forgot to change it here. So just go ahead and do it here. Pay attention to Power Schools or Canvas for where the grades are at. So if you don't have anything missing there, you're okay. All right.
exam?
You only have to be here if you are having to take an exam. So it is CTE exams, EOCs, and I guess those are the only two state.
When's your exam?
You cannot leave until the entire testing session is up, but yes. So like you can't leave as soon as you finish the test, but once they have announced for that day that the testing sessions are done, then you can leave.
Wait, so what if I have taken an exam like our last day?
Wait, which?
You should, if you have to take, now on Friday is a regular class scheduled day, but it will be teacher-made exams. So if the only class you have to take a teacher-made exam for is fourth period, and so, well, are all of yours teacher-made exams, or do you have any CTE classes? So if all of yours are teacher-made exams and the only one you have to take is fourth period, then you would only have to be here for fourth period that day.
So if I just take first and second, I can just leave after that.
Yeah, unless you, like if you have a CTE class where you're going to have an exam on Monday, Tuesday, or Wednesday, you're supposed to be here for that class also, because that'll be a regular class day for that class, and you will probably be reviewing for that exam. So you're supposed to be there. But if you are, so basically if you are exempt from your teacher-made exam, you may stay home. Otherwise, you need to be here.
When is the teacher-made exam?
Friday next week, yep. You have to have at least a 70, and you cannot have any missing
And
assignments.
when's the day they're turning the hour?
Wednesday, because I'll have to let you know Thursday whether or not you got to be here. So I need everything Wednesday. So,
You guys come in and one day.
yes, like today, yeah, to make up quizzes and stuff, yes.
I just got one yesterday.
Yeah, so like the rest of the stuff can be done from home. So if you have questions about it, it'd be better if you come for smart breakfast tutoring. But if you need to stay after for a little bit, so that way you don't have to miss. Okay. Friday morning. Okay. Yeah, that'll be good. Just come tomorrow morning and we'll look at anything you have questions on, because I think everything you have left can be done from home. Okay. Yes. Right now you need to be doing this assignment. Yes. If you finish Delta Math, you can work on it, but let me change the date so it shows up where it's supposed to be. It's 5.1 is the one you're doing. Right now it's saying it's late credit, but it's not really late. I just have the date set incorrectly. Alright, it should show up where it's the one that you're supposed to do right now. Oh, I think so, because it is a coordinate pair, so.
do that though. See, I put that. Did I? I think I just did.
You graphed
The
one
other
of them
side.
wrong. Let's see. The 3x is supposed to have a positive slope, so you need to go up 3 to the right one, not down 3.
Okay.
All right, and so. All right, so I think everybody is moving on to their Delta Math now. Any questions from the notes?
Did you need to check mine? I didn't show you.
You check your own here at 4. You should have 2, -1.
No, I mean, I know.
7's no solution. 3, 1, and 2, 2. Okay, so everybody's working on Delta Math. I need to post this